Hi everyone, welcome back to our channel. In this video, we will discuss some great circuit simulators. Without further ado, let's start with Tinkercad Circuits by Autodesk is a free, browser-based platform that combines the simplicity of drag-and-drop design with real-time electronic simulation, making it an ideal choice for beginners, students, and educators. There's no need to install any software, just create a free account at their website, and you're ready to go. Apart from the circuit simulator, the Tinkercad also offers 3D modeling, for which it is widely known. So, if this is something of your interest, you can try it as well. Once inside the circuit workspace, you can drag components like LEDs, resistors, capacitors, switches, sensors, motors, ICs, and even Arduino boards onto the canvas from the panel on the right. Components snap into place neatly, and the wire tool lets you connect everything logically. You can even change wire colors for better clarity and organization. Tinkercad supports real-time simulation, so you can immediately see how your circuits behave as you toggle switches, send sensor inputs, or run Arduino code. It also includes built-in virtual instruments, such as multimeters and oscilloscopes, letting you measure voltage, current, and waveform behavior just like you would with real lab equipment, making it perfect for learning and debugging. For Arduino-based projects, Tinkercad offers block-based programming for beginners and a text editor for Arduino, so you can experiment with actual microcontroller logic. There's also a step-by-step debugger built in, allowing you to pause and inspect how your code interacts with the circuit in real time. One standout feature is the ability to export circuit snapshots as images. Projects can also be shared via direct link or even embedded in other platforms. Tinkercad also provides guided tutorials and sample projects, walking users through basic electronics experiments and Arduino tasks in an intuitive, easy-to-follow format. There's also a very big library of projects being added every minute by users worldwide. Now, many of you might not have heard of this simulator. It's called Crumb. It created quite a buzz when it was first launched. What sets this simulator apart is its visual, engaging environment that mimics the feel of building circuits on a real breadboard. Yes, instead of prototyping a circuit in 2D, here you get a 3D environment. Building circuits in a real-like breadboard, complete with jumper wires and other active and passive components. This simulator is available for Windows and Mac OS through Steam, and it's also available on the App Store. Although it's a paid tool, it's quite affordable, priced at around $9. Once you purchase and open the software, you're welcomed with a clean, playful interface and a large workspace. At the top menu, you'll find options like the breadboard and various electronic components. To start, add a breadboard into the workspace. You can zoom in and out or pan around to explore the full 3D view. To place any passive component, just click on two breadboard holes, and the component will appear there. When you pan and zoom around, you get a full 3D view of your circuit, which looks pretty cool. After placing all the components, the next step is wiring them. Click on the wire icon, pick a wire color, and then click on the breadboard holes you want to connect. Next, add a power source from the top menu and connect it using wires. Once everything is set up, flip the switch on the power supply, and your circuit will start running, just like building a real-life prototype. If you want to see the waveforms, click on the scope icon and then select the component you want to monitor. The simulation runs in real time, and you can even adjust the simulation speed and step size through the settings icon. One of the best things about this simulator is how interactive it is. Just hovering over components gives you live feedback like current flow and pin labels, helping you understand the circuit better. You can even build circuits using an Arduino Nano. Upload your code through the built-in code editor, just like you would in the Arduino IDE, and view the output in the serial monitor. However, one downside is that there are only a limited components in this simulator, for example. If you want to experiment with some sensors on Nano, there are none. Also, there is no option to move the position of the existing component on the breadboard. You have to delete and re-add it. While Crumb doesn't offer complex analysis tools like spice-based platforms or waveform plotting features, it excels at making electronics fun and interactive. If you're someone looking for a tool that can not only design PCBs, but also perform advanced circuit simulations, you should definitely check out Altium. Altium Designer lets you easily move from drawing your circuit to simulating its behavior, and then straight into PCB layout, all without needing multiple programs. On top of that, Altium 365 takes your work online. It allows you to view, edit, and share your designs from anywhere. You can even invite team members or manufacturers to review your projects directly through a web browser. They can leave comments, suggest changes, and double-check important details like component placement or spacing without needing the full software installed. This makes working with teams or preparing for production much easier and helps you catch mistakes before they become expensive problems. And the best part, you can get a 25% discount if you register using the special link we've added in the description. Give it a try. It might just be the upgrade your workflow needs. Falstad Circuit Simulator is a brilliantly simple yet surprisingly powerful browser-based tool for simulating electronic circuits in real time. Created by Paul Falstad, this simulator doesn't require installation or sign-up. Just head to the website, and you're instantly dropped into a fully interactive circuit playground. To build a circuit, simply right-click on any empty space within the canvas to view a wide array of components, starting from simple passive components to digital ICs. To place the required component, you have to select it first, then click and drag it on the workspace. You can place as many as you want by repeating this dragging motion. To come out of this object selection mode, just hit Escape on your keyboard. To connect two components, click on Add Wire and drag to join the end terminals of the components. Falstad also includes a huge library of built-in example circuits, neatly organized into different categories that you can check out. This makes it an excellent learning resource, allowing you to explore popular circuits. Now to simulate your circuit, just click the Run Stop button. Below this button, there are two sliders to control the simulation experience. The simulation speed slider that adjusts the simulation time, while the current speed slider adjusts the visual speed of the current flow animation. One cool feature of Falstad is the ability to plot real-time graph of different circuit parameters. For example, here the voltage and current waveform across the capacitor is being displayed. You can change the scope properties or add a new one by clicking on a component and selecting the View in New Scope option. After this, you can save your designs, export them, or even share them as interactive URLs, making collaboration way easier. While it doesn't support microcontrollers or embedded programming, it excels in simulating various electronic circuits in real time. QUCS, or Quite Universal Circuit Simulator, is a free and open-source circuit simulator that's particularly well-suited for non-linear and RF circuit analysis, making it a great tool for intermediate to advanced users who want detailed control over simulation parameters. After downloading and installing the software, opens up a slightly old-school but functional simulation interface. The main component dock is located in the left sidebar. Simply click on a component to add it to the workspace, and hit the Escape key each time to exit component placement mode. To change the parameters of a component, right-click on it and choose Edit Properties, allowing you to set values, names, and model types. To connect components, click on the wire icon from the top toolbar, then click between the terminals you wish to connect. And don't forget to add a ground node, as simulations won't run without it. Once your circuit is built, the simulation process is a bit more typical. First, you have to save your project. After that, insert a simulation block from the simulation menu into your schematic. QUCS supports multiple simulation types: DC, AC, S parameter, transient, harmonic balance, and more. Ideal for those dealing with high-frequency or non-linear designs. Set up the simulation by configuring its properties and specifying equations you want to evaluate. Then click Simulate to process the data. But wait, the process is not completed yet. After this, switch to the Diagrams section, where you can drag different plot types, such as Cartesian plots, into the workspace. You'll then manually define which variables to visualize, such as voltage at a node, current through a branch, or calculated results from your equations. This manual plotting approach may feel tedious to beginners, but it gives precise control over what data is displayed and how. Every circuit is a web-based interactive circuit simulator designed to make experimenting with electronics easier. To get started, you'll need to sign up for a free account, which allows you to explore the platform and create up to 5 circuits. But if you're serious about tinkering or learning electronics in depth, a one-time payment of $15 unlocks lifetime access with unlimited projects, making it one of the most affordable premium simulators out there. Once logged in, you will see the central workspace, where you can build your circuits. Just above this workspace is a horizontal menu bar containing basic circuit components and sources. Simply click on a component, and it will appear in the workspace. To connect the components, just click the end terminals of 2 elements, and they will be linked automatically by a wire. On the left side, you'll find a menu with several tabs: access to your personal projects, a library of pre-built example circuits, and a vibrant online community where users from around the world share their circuit designs. Clicking on any example starts the simulation instantly. At the top, you can see the waveforms of different circuit parameters, just like in an oscilloscope. On the right side, a brief description of the selected circuit is displayed, which makes it especially helpful for those learning how things work and want to explore more. At the bottom of the interface, there's a pause-play button to control the simulation, a dial to adjust the simulation speed, and a screenshot button that lets you capture your circuit with either a white or black background. Every circuit also works seamlessly across platforms, including mobile devices, making it great for on-the-go learning or quick prototyping. Circuit Lab is a powerful browser-based circuit simulator that strikes a great balance between user-friendliness and professional-level simulation tools. To use it, you will need to create an account and verify your email, and you'll be welcomed into a clean and intuitive interface. To help you get started, they even have step-by-step tutorials provided here. Otherwise, you can start designing right away by clicking on New Circuit, which opens up the main schematic workspace. On the left-hand sidebar, you'll find a well-organized library of components. Simply drag and drop them onto the canvas. Connections are made by clicking and dragging from one terminal to another, and the software automatically draws clean, sharp wires to complete the path. Double-clicking on any component opens a parameter editor where you can set values and assign labels. Clicking the Simulate button from the lower panel or using the Run option from the top menu gives you access to a full range of analysis tools: DC sweep, AC frequency response, and transient time domain simulation, which is really helpful in analyzing the circuit behavior. Results are displayed using high-resolution, interactive plots that allow you to analyze voltage and current behavior across any node or branch in your circuit. These graphs can also be exported for reports, documentation, or presentations, making it suitable for academic and professional projects. Though Circuit Lab is known for its accurate simulation results, it's not free to use. Yes, they offer a free version, but it is time-limited. You can only use it for a restricted number of minutes per day. Beyond that, it requires a paid membership, and the subscription can be quite expensive for students or hobbyists on a budget. LT Spice is one of the most popular and powerful free circuit simulators available, especially among professionals and advanced users working on analog and power electronics. Developed by Analog Devices, it's a desktop application that offers accurate simulations with support for a vast library of components. After downloading and installing LT Spice, you can begin by navigating to File, New Schematic, which opens the design workspace. Although the interface may appear a bit dated at first glance, don't let that fool you. LT Spice is a simulation powerhouse with speed, precision, and industry-level capabilities. To add components, use the top toolbar, where you'll find symbols for resistors, capacitors, inductors, voltage sources, and more. Components can be clicked and placed directly onto the workspace. Press the Escape key to exit the placement mode once you're done. You can edit the values or names of any component by right-clicking on its label. And in some cases, you can right-click the component itself to select standard models or predefined values. Connecting components is simple. Click and drag wires to make connections. To make learning easier for you, LT Spice also provides a collection of pre-built example circuits, which can be accessed via File, Open Examples. To run a simulation, click on the green icon in the toolbar, which opens a dialog to choose the type of analysis you want to perform: transient, DC sweep, AC analysis, and more. Once simulation starts, you can click on any node in the circuit to plot voltage waveforms, or click directly on a component to visualize current through it. Multiple waveforms can be displayed in a single graph, each automatically color-coded with its label shown at the top, making it easy to compare signal behavior across the circuit. TI, Tool for Interactive Network Analysis, developed by Texas Instruments, is a powerful yet free offline circuit simulator. To use it, you first need to create an account and download the software. Although the interface may look basic or a bit old school, don't underestimate its capabilities. TI offers solid simulation accuracy and a wide range of analysis features that make it a great companion for analog, digital, and mixed-signal circuit design. At the top of the workspace, you'll find a menu bar packed with all the essential components you need to build a circuit. Just click and drag a component onto the canvas to place it. Double-clicking any component opens a dialog box where you can modify its parameters and assign values. For circuit connections, simply click on the pins of two components, and a wire is automatically drawn between them. Once your circuit is built, the next step is to simulate it. For this, head to the Analysis menu, where you'll find various options such as DC analysis, AC analysis, transient, noise, and even Fourier analysis. These features allow you to measure voltages, currents, and frequency responses across the circuit and observe real-time behavior. One of the unique features of TI lies in its visual customization options. You can switch the default symbol set or even enable a 3D component view, which gives your schematic a more realistic, hardware-like appearance. This can be helpful for learners who are familiar with different regional circuit symbols or want a more tangible representation of their designs. While it may not offer the polish or cloud integration of web-based simulators, TI is great with its stability, analysis variety, and strong focus on precision. Proteus is a professional-grade electronic simulation and PCB design software developed by Lab Center Electronics, widely used by engineers, students, and educators alike for simulating microcontroller-based projects and complex analog-digital circuits. Unlike many other simulators, Proteus goes beyond just analyzing voltage and current. It actually allows you to simulate embedded systems with real firmware. You'll need to download and install the desktop software, and while it's not free, a demo version is available, and educational licenses are often accessible through schools or universities. After launching Proteus, you can begin by creating a new project or schematic. The interface may feel a bit dense at first, but it's highly modular and packed with tools. Components are added using the Pick Devices tool in the left panel, where you can search from a massive library of elements, including microcontrollers like Arduino, and even sensors, displays, and more. Simply drag and drop components onto the schematic area to place them. One of Proteus's standout features is its ability to run live simulations of code running on microcontrollers. You can load your compiled hex or ELF files into the MCU component, and the software will simulate how your actual code interacts with the rest of the hardware circuit. This makes it a favorite for embedded system development and debugging. To run simulations, click the play icon in the toolbar. You'll see dynamic animations like LED blinking, signal changes, all tied to your code and components. Proteus also provides instruments like virtual oscilloscopes, logic analyzers, signal generators, and multimeters, which can be placed into your schematic to monitor signals, voltages, and current flow across different nodes. Proteus also includes a powerful debugger, which allows for step-by-step code execution, breakpoints, and register inspection while the hardware simulation is running. If you're also into hardware design, the suite includes a full-featured PCB layout tool, letting you design, route, and even 3D preview your boards after testing the circuit in simulation. The only downside is that it's quite expensive and not very beginner-friendly. We recommend it only if you're truly passionate about electronics and want to dive deeper into circuit simulation and how hardware and code work together. So, with that, we come to the end of this video. Choosing the best simulator isn't easy. It all depends on what kind of user you are and what you're trying to achieve. We've created a list of pros and cons for each simulator, so you can check it out and decide which one suits you best. If you enjoyed this video, make sure to hit the like button and subscribe to our channel to keep supporting us. We'll see you in the next video. Until then, goodbye.